Okay, this is 10.2 homework help. The first problem wants us to evaluate this integral right here, interpret it in terms of area. So an integral is area underneath the curve, and so this is the curve we're dealing with. You might recognize that this is a circle from the equation for a circle. If you solve for r, you'd get plus or minus the square root of 49 minus x squared, where the radius is 7. I can show you that really quickly if you want. It's x squared plus y squared equals 7 squared, which is 49, right? Well, just solve it for y, and you get this. Now, they're only saying the positive part, so we're only going to graph the positive. So it's a circle centered at 0, 0 with a radius of 7, and we're trying to find the area of the top part. We can just use the formula for area of a circle, pi r squared, but then take a half of it because we're only doing the top part. So that should be our answer, 1/2 pi times 7 squared, which is 49. So 49 over 2 times pi. Okay, the next problem then says, for the function f whose graph is given below, list the following quantities in order from smallest to largest. So I'm going to try to give like an approximate numerical value to these. It's not going to be exact, but it'll help us solve this problem quicker. So from 0 to 8, 0 to 8 would be from here to here. This is like -4 maybe, and this in here would be like, I don't know, 10, let's just guess and say, as the area underneath that curve. So then we're left with positive like 6. 0 to 3 then would be -4. 5 to 8, which would be from 3, 4, 5 to 8 would be here to here. That looks like a positive value, like maybe positive 8, let's say. 0 to 5, 0, 1, 2, 3, 4, 5. You look at this area, and this area, it looks like we have a -4 here and maybe a positive 4 there, so it looks like it'd be about 0. So let's try that. Let's try B, D, A, C, and that worked perfect. Okay, the next problem wants to evaluate the integral here by using areas. So the first one goes from 0 to 2 right here. That's just a triangle. That's 1/2 base times height. So the base is 2. And the height is 2, so that's just 2. And you're just going to do the same thing for the rest of them. The next one, 0 to 5, is this whole length here. So that's a trapezoid, 1/2 height times base 1 plus base 2. So base 1 is 1, 2, 3, 4, 5. Base 2 looks like it has length 1, and height is 2. So that gives you 6. 5 to 7 is from here to here, which gives us another one of those triangles that we had of area 2. And then so 0 to 9, and this should be -2 actually, because we're going down here. Okay, the last one, 0 to 9, then is the whole thing. We already have, this is -2, and this is positive 6. So we could break this off into a rectangle knowing that that's 2, and then we could find the area of this little triangle, 1/2, the base, let's say, is 2, and the height, let's say, is 1. So this should just be 1. And these are both negative because they go down. So then we can add those up, and it looks like we get a positive 1 total. Okay, the next question gives us an integral here of this function from 4 to 4. Now, we should recognize that if we're finding the area underneath the curve from 4 to 4, we're not moving at all here, so there should be no area underneath whatever this curve looks like, which I have no idea. So it should be 0. You can always type this in your calculator as well, though, if you go to, I've typed it in here, but if you go to alpha window and do function integral right here, 4, and then you can just enter this whole thing in, 4, 4, and type in the function in here, and then right here is type in an x, because we're taking the integral in terms of x. Okay, the next problem says to estimate this integral right here from -3 to 3. So we're looking for the area underneath the curve from -3 to 3. So we'll just kind of count these up. There's 1, 2, I don't know, this would be 3, these two together, maybe 4 here, say 5 and 6, and about 7 maybe. Ish, and then subtract the area underneath this, which maybe 2. So I get about 5 if you subtract 7 from 2, and that worked. So it doesn't have to be exact, but the next question then says between 0 and 3 and between -3 and 3, which has the better area. So 0 and 3 would be it looks like positive 1 and -2 would make it like -1, and we know -3 to 3 was 5. So obviously, -3 to 3 is the bigger area. Okay, the next problem says, suppose you're driving a car 80 miles per hour and decelerating at 16 feet per second. So let's write a velocity time equation, given what they gave us here. we have 80 miles per hour, which I'm going to need to convert that because we have feet per second for acceleration. So I'll take the 80 miles per hour and we'll multiply by, there's 3,600 seconds in 1 hour. So 1 hour is equivalent to 3,600 seconds. That way the hours cancel. And then let's get rid of the miles as well. So 1 mile, so the miles cancel, is equivalent to 5,280 feet. And that way we're in feet per second. And that gives us about 117.3 repeating. So let's do 117.3 repeating is our initial speed in feet per second. And then we're going to subtract 16t. Now, if you're wondering why to subtract 16t, I would look at the units for that, because what you have for units is 16 feet per second squared. And we're going to multiply that then by t, which the units on that in red are in seconds. So the seconds would cancel and we'd get feet per second, which is a speed. And that's what we want. We want to subtract a speed minus another speed. So the units work out, and that's a lot of times that helps me write equations. So here's our velocity time equation. Now, if it wants us to ask the first question, which is how long will it take you to stop, that's where the speed is 0. So just solve this simple equation. And obviously you're going to get 117.3 repeating divided by 16 here. And then during that time you'll travel how many feet? Well, we're going to take the integral from 0 to 117.3 repeating over 6 of this equation, 117.3 repeating minus 16t. And that's in terms of t. And I can do that right in the calculator. That's going to give me an answer of, go to alpha window, we'll do 4. Function integral from 0 to, and I did that and got 7.3 repeating. So I'll just type in a few 3's here. And then we have 117.3 repeating minus 16t. Well, I'll use x for that in terms of t or x. And whoops, not graph, but hit enter. And we get 430.2 repeating. Just make sure you enter in a couple decimal places here. And then the next question says, assume it takes you 1 second to react to emergency before you start braking. Well, if you want to take this distance that takes you to stop and add on the distance that it takes you to go when you're going 1 second, which the speed that we were traveling was the 117.3 repeating times 1 second is the distance, because distance equals rate times time. So take the rate that we're traveling at a constant rate and multiply it by the time, and add that quantity of distance on there, because that's how long, how far you go in 1 second. So if you do that, you end up getting 547.5 repeating. And just to remind you of why we did the integral for part 2, in case you don't remember from the notes, if you have a velocity time graph, velocity time, whatever this thing looks like, it's a linear function with a negative slope. So you could have used area of a triangle to solve this as well. But keep in mind that our velocity was in feet per second and our time was in seconds. So when you multiply those, which is what you're doing when you're finding the area underneath the curve, feet per second times seconds cancels and you're going to get a distance. So the area underneath the curve of velocity time graph or velocity time function is always going to give you distance. Okay, the next problem says a stone is thrown straight up from the edge of a roof 700 feet above the ground at a speed of 10 feet per second. Let's use our distance equation to write a distance time function first. This is off the formula sheet. It's negative 32t squared. I'm sorry, it's not. It's negative 16t squared plus the initial velocity in the y, which is 10 times t, plus the initial height, which is 700. On the formula sheet, I think it's written like this. It's under chapter 6, but I use s instead of d. I think that's what the book uses. And then, this initial velocity stands for the initial velocity in the y, and that's the initial height, s sub 0. Now from here, if we remember what we learned about derivatives, the derivative of the distance equation gives us velocity equation. So to find the derivative using the power rule, we multiply the power down and lower the exponent by 1. So follow that process. This is 1 times 10. You get 10 t to the 0th, and that's it. So there's your velocity function in terms of time. And then the acceleration function in terms of time is the same thing, the derivative of velocity. So take the derivative and you just get negative 32, which we already know because it's a constant acceleration of negative 32 feet per second on Earth. So we don't have to write, that's not helpful. But we've got distance and velocity in terms of time, which is helpful because then we can answer these questions. The first one, remember the acceleration due to gravity is this. How high is it 6 seconds later? There's different ways to find out how high it is 6 seconds later. You could obviously just plug in 6 into your distance time function. But I'm going to do actually the integral of the velocity because that also gives me distance. So I'll integrate it from 0 to 6. And that gives me negative 516, but don't forget to add the original 700 because we're already starting 700 feet above the ground. And that would take us to 184. And also don't forget the units. It does say units right here, so that's feet. Okay, the next question, at what time does this stone hit the ground? There's probably different ways to answer this as well, but the easiest way is to plug in 0 for distance and find out what time that is using the quadratic formula. I did that with a program in the calculator for mine and got about 6.934, and don't forget the seconds, the units. And the next question, what's the velocity of stone when it hits the ground? Just plug in that time, because at that time it hits the ground, so plug in that time to the velocity equation and we'll get the velocity, which in this case gave me negative 211.9, and don't forget the feet per second. And this should make sense as well because we're starting, at 700 feet off this cliff, and we're throwing the rock, and before it hits the ground, what we're talking about here is the velocity in the y. So you look at the velocity in the y, obviously the velocity is acting straight down, and it's going to be 211.9. So this we're talking about here in this problem is all vertical velocities. It's a separate relationship for horizontal velocity as we talked about, but this problem is the first equation we gave was the distance vertically in terms of time, and this equation was the vertical velocity in terms of time. Okay, the next problem gives us a velocity function in terms of time right here. It says find the displacement and the distance traveled from -1 to 4. So we're going to need to draw a graph of this. Here's -1, 1, 2, 3, 4. We know what this thing looks like. It's a cubic function. We can factor out a t squared, and we're left with t minus 2. So that means there's zeros at 0, and there's zeros at 2. Now, the 0 at 0 has a multiplicity of 2. What that means is the function touches and turns around there. And then it's got an odd multiplicity at positive 2, so what that means is the function changes signs there, if you remember from our study of polynomials. So now what we want to find is the area underneath the curve. The displacement is just the total area, so like, this little branch right here, plus this little branch, plus this, all the way to 2, -1 to 4, all the way to 4. So plus this part. So the displacement is going to be, this positive, and then we're going to subtract these amounts for the displacement. And to get that, we can do that in the calculator. Just type it in, -1 to 4, do alpha window, function integral, and you get 20.416 repeating. And don't forget to enter the units, which in this case is meters on that. So that's the displacement. That's basically where we're at after 4 seconds, from -1 to 4 seconds. But we also want to answer the question of how much total distance have we traveled, which is a completely different question. The total distance that we've traveled now is we would count this area underneath that curve right there and this area as positive values. Because we traveled distance, we just happen to travel in the opposite direction for those. So we would have to add those as positive. So the best way to do that in your calculator is to now just grab this and put enter, and it'll put it down here. And then you can change the range. So I did from 2 to 4 and found this area right there as 22.6 repeating. And then I found this other area right here by just changing it and doing from actually that one was from 0 to 2, which gave me 1.3 repeating. So I just wrote that as 1.3 repeating, positive value. And then the other branch right here is from -1 to 0, which is -9.16 repeating. So let's put that as 0.916 repeating. Now you just add these up as positive values to find the total distance traveled. 24.917